Are you ready for some science?
Yo, what is up, science peeps? Floyd the Teach here. Wanted to make a video for you guys. If you are in my physical science class, you know that we have been talking about gases, and so I have a very interesting video I want to show you that has to do with gases. Okay, this is a very special gas to me, one that's fun to play with, one that you may have heard of. It's actually the gas that is most common in Earth's atmosphere. So if you know what gas is most common in Earth's atmosphere, yes, the gas is nitrogen. I have some nitrogen with me. You may be wondering, well, okay, well, what's so exciting about nitrogen? It's just air, right? Well, yes, but I have a very special type of nitrogen. I have liquid nitrogen. Yes, we are gonna do a cool video with liquid nitrogen, and it's gonna have to do with volume, pressure, temperature, all those things we've been talking about this week in class. So I hope you guys are pumped for this video. Alrighty here, so I have in here some liquid nitrogen, okay? So we've talked about, ooh, nice and steamy. If you know, liquid nitrogen has to be extremely cold, okay? Notice I've got my special gloves on here because I do not want to touch any of this stuff. I don't know if I can pick it up and kind of show it to you guys. If I blow in it, it's kind of cool. Okay, so if you look up nitrogen, you'll notice that it has a very low boiling point, okay? You can see it's kind of steamy in there. That's because here at room temperature, or outside temperature that is, we are above its boiling point. Nitrogen, or liquid nitrogen that is, boils at negative 320 degrees Fahrenheit, okay? Or if you put that in Celsius, negative 196. So obviously we are above negative 320 Fahrenheit here, just outside in the shop. It's actually not going very much, which is kind of interesting, but currently it is in the process of boiling. And you can see that's what all that steam is there, okay? It's boiling off. And actually I wonder if the reason it's probably not boiling very violently is because the air down in the cup is actually pretty cold. If I dump it out, you could see it'll boil really quickly. Just pour some on the ground there. Look at that. Just kind of, boom, see? Steamy, boily, looks very mystical. Okay, this stuff is super cold. Okay, so you guys know we've talked about how pressure and volume and temperature are kind of related in different gases, right? We've talked about Boyle's law. What does Boyle's law tell us? Boyle's law says that pressure and volume of a gas are indirectly proportional, which means that if the pressure goes up, the volume goes down, right? Or if I make the volume go down, the pressure goes up. Okay, so we know that. We've also talked about Charles' law. Charles' law says that temperature and volume are directly proportional. So if I have a gas and I increase the temperature, the volume will go up, it'll expand. If I decrease the temperature, then the volume will decrease, right? It'll contract, okay? But with the activity I want to do here in this video, I want to relate pressure and temperature, okay? Boyle's law and Charles' law both involve volume, okay? But I want to do an experiment where volume is constant. Now when I put the liquid nitrogen in here, we know it's going to continue boiling. We know we're going to have gaseous nitrogen. But because this bottle cannot change shape or volume, the volume of the nitrogen can't change. It has to stay at constant volume. But we know that the temperature is increasing. So the question is, as temperature increases, what happens to pressure? You probably already have an idea of where this is going. As temperature increases and volume doesn't change, constant volume, we probably think that the pressure will increase. So I wonder what happens when you take increasing pressure and put it in a closed container. Let's find out. Amount of liquid nitrogen into this bottle. Just gonna fill it up really nice. Fill it as much as I can. Don't mind it spilling. Okay, I'm gonna close the lid. Oops. Try to close the lid. It's kind of hard to film yourself and do the experiment at once. I need a science partner to help me out. All right. Like that. We've got that there. Hopefully I closed the lid pretty well. So we've got our liquid nitrogen. It is boiling. Pressure is increasing very rapidly. Let's see what we have going on here, what happens. do this video outside, but it is so windy, I had to bring it in here. Woo! Dang, that totally took off. It seems that the bottom froze off of it. Well, let's see. Oh man, that is icy cold. You ripped it open. Ooh, that is super cold. It's very frosty. All right, well that wasn't bad. Well, you know what they say about explosions. You never do them just once. I have a second bottle. Aha. Let's do this again, see if we can do this better. Okay, round two. Let's see if I can do this one better. All right, got our liquid nitrogen. I'm gonna pour a bunch in there as much as I can. Try to get it nice and full. I really need a funnel. That's what I should be doing this with. Okay, I'm gonna pause the video so I can really get the lid screwed on tight. All right, lid's on. Let's see what we can do here. Take two. You can see the bottom of the bottle is frozen. It's so frosty. Any moment now. And it's gone. I think it's gone. There's literally no bottle left. Gosh, it's like shreds. There's nothing here. I'm looking around for pieces of the bottle. There's nothing left. Totally pulverized. There's another piece. Crazy. There you have it. There is the remainder of this experiment. One bottle mostly intact. The other one, not so much. Well, if that doesn't teach it to you, I don't know what will. So how are temperature and pressure of a gas related? Obviously, when the temperature increases, the pressure increases. And when the pressure increases, things go boom. This stuff is kind of fun to play with. You just pour it out. Look at that, you just kind of throw it on the ground and just boils away. There you go, there's the last of it. Ooh, quite frosty, I'd say.